Welcome to EduPorm EdTech. You're watching expert chemistry lectures with Abhinav Gaur. Today in this video we will study about the stoichiometric point defect. The stoichiometric point defect. So in case of stoichiometric point defect, what happens is that the stoichiometry of crystal remain unchanged. Okay, it remains unchanged. And what is the meaning of stoichiometry remain unchanged? It simply means that the crystal is neutral. Okay, the crystal is neutral. And when can the crystal be neutral? When the number of cations are equal to the number of anions. So, a stoichiometric point defect is a defect in which the stoichiometry of crystal remain unchanged. The crystal is neutral and thus the number of cations and the number of anions present in the crystal after defect are same. Okay, after defect are same. Now, the stoichiometric defect is of two types as we already discussed in the previous lecture. So, the first type is our Frenkel defect. The first type is Frenkel defect and the second type is Schottky defect. Now let us understand what happens in case of Frenkel defect and what happens in the case of Schottky defect. So this is a cation, then anion, cation, anion and a cation, then anion, cation, anion, cation and anion. Then we have cation, anion, cation, anion and cation. Now in case of Frenkel defect, what will happen is that any of the cation, okay, any of the cation, that means any of the positive charge, will leave its lattice site. Okay, it will leave its lattice site. That means it will leave the site where it should be present in the crystal and it will occupy a site other than lattice site, which we already studied, that the site is called as interstitial site. Okay, so it will occupy the interstitial site. So in such type of defect, we can see that no mass leave the crystal. Okay, that means the mass remain unchanged. Second thing is that this defect is an example of interstitial defect. Okay, it is an example related to interstitial. Okay, it is an example related to interstitial and it usually occurs where the cation is smaller. The cation is smaller as compared to, or we can say with respect to, the anion. And as we know, the density is directly proportional to mass, and since the mass is not changing, so the density will be same. The density will remain same. Okay, and the example where it exists, as I already said, the cation will be smaller and the anion will be larger with respect to the cation. So the examples include ZnS, that means zinc sulfide, and AgBr and AgBr. Okay, so Frenkel defect is a defect in which the cation, okay, the cation, any of the cation or any of the cations leave the lattice site, that means the site where they should be present, and they occupy the interstitial site, that means the site other than lattice site within a crystal. Now, as no mass leave the crystal, so there is no change in mass and it is a type of interstitial defect. Cation occurs where cation is smaller with respect to anion. There is no change in density. Example include zinc sulfide and AgBr, silver bromide. Now, in case of, and one more most important thing is that here we can see that the number of anion are equal to the number of cation. Okay, the number of anion are equal to number of cation. So the stoichiometry remain undisturbed and the crystal is neutral. Okay, this is very important point. Now we will study Schottky defect. Again we have a cation, anion, cation, anion, cation. We have anion, cation, anion, cation, anion. Again we have cation, anion, cation, anion and anion and cation, right? So this is our crystal geometry. Now let's say that one cation and one anion leaves the system. Okay, they permanently leave the system by making vacancies. Okay, so one cation and one anion, they left the crystal geometry. So this is an example of vacancy defect. Okay, this is an example of vacancy defect because it is arising due to the vacancy, and in this case same number of anion and cation, same number of anion and cation leave the system. Okay, so as same number of anion and cation are leaving the system, so we can say that the number of cations are still equal to the number of anions, so the stoichiometry will remain undisturbed. And as the mass is decreasing, okay, there is loss of mass, so mass is decreasing, so this defect also result in decrease of density. So the density will decrease if the crystal show Schottky defect. Okay, so this is all about Frenkel defect and Schottky defect. In case of Schottky defect, the examples are NaCl, Cd, Cl, etc. Okay, one more important point is that Schottky defect is shown where the size of cation and size of anion is nearly same. And one note point and very important point, that AgBr, that means silver bromide, it shows both Schottky defect as well as Frenkel defect. Okay, where Frenkel defect is shown when cation is smaller as compared to anion, whereas the Schottky defect is shown when the cation and anion are nearly equal in size. They will not be perfectly equal but nearly equal in size. Thank you.